Hey everyone, this is Mr. Z here with a tutorial on RobotC. In this tutorial, we are going to be programming our test beds to do a very simple function. We're going to have our two motors over here spinning. So let's go ahead and get started. What I'd like you to do is open up RobotC, and once inside RobotC, even if it doesn't quite look like mine, I want you to go to File, New, New File. So click on that. It's going to start a new program. You should notice that there's some writing over here. And we need to make sure that we're programming the right kind of robot because this program can actually program 3 different types of robots. So head over to the button here that says Robot. Click on it. Go over to where it says Platform Type. And if you have Vex IQ selected, let's just say you did, so it looks like Vex IQ. Go over to where it says Vex Robotics and click on Vex 2.0 Cortex. Okay, once you've done that, let's start programming. The first thing we're going to need to do is declare our two motors. It's something we do in programming to tell the computer that the motors exist. To do that, head over to where it says Motor and Sensor Setup. Click on it, and you're going to notice a page that looks like this. It has tabs on the top. And since we're working with motors, let's go to the tab that says Motors. Over here, you're going to notice that there are 10 ports. Just like on a Cortex, there are 10 motor ports. What I'd like you to do is plug the left motor into port 1 and the right motor into port 10. So go ahead and plug those in now. Once you've done that, for port 1, I would like you in all lowercase in just one word, I would like you to write left motor. Okay, all lowercase, one word. And for port 10, I would like you to write right motor. All lowercase, one word. The capitalization and lowercase means something in programming, so we usually just declare our variables in lowercase. For the type of motor, we are currently using Vex 393 motors. So click on that, and for the other one, Vex 393 motor. Now, if you're ever programming a robot and it's going in the wrong direction, one of the motors, you just need to click on this reverse button and it will reverse the motor, like that. Okay, but we got these two good. Let's press apply, and you'll notice that right away it adds it to the code. So it's declaring that these two are plugged into ports 1 and 10. That's pretty cool. But for our main program, we need to write it in between these two curly brackets. That's why it's called main. It's the main program. It's very important that you do not accidentally delete any of this. Right between these two. And if you need more space, you can just press enter on the keyboard, while writing. It doesn't actually matter. As long as you're writing in this empty space, it's going to be fine. Now, programs read from top to bottom, so we need to write from top to bottom. So somewhere near this curly bracket up here, I would like you to start writing the program. And we're going to keep it really simple. We're just going to turn on both motors. So to turn on a motor, you have to say motor, square bracket, that's the thing located right next to the P on the keyboard. You have to say the name of the motor, so left motor, and then close it off with a square bracket. You have to set a speed, so I'm going to do space equals space, and I'm going to set the speed to 127. Now in the world of motors, motors move from speed 0 to 127, and if I wrote that down on a Word doc, just to explain that real quick, and I'm opening up the Word doc, motors go from 0 to 127. At 0, they're at 0% speed. At 127, they are at 100% speed. So just keep that in mind. Is this how it's written? So if you want to go at a full speed, you're going to go at 127. Okay, so that's going to be set. And at the end of the 127, and most lines of code, you have to put what is known as a semicolon. It's located right next to the L on the keyboard. and it looks like that. Okay, enter. We're going to do the same thing, but now with the right motor. So square bracket, right motor, close off the square bracket, space equals space, and then say the speed 127, and then close it off. So if you wanted to go at half speed, you could just take this number and divide it by 2 and type that in. So it's about 63. So there we go. There's our first program. We need to make sure that we wrote the program without any errors. So there's a button up here that says compile program, and press it. The first time you press it, it's going to ask you to save the program. So give it a name of something you won't forget. I'm going to call mine motor 1. That's going to be the name of my program, and then I'm going to press save. And then it's going to run the code, and if there's no errors, nothing, no X marks should show up down here. But like, let's say I forgot a semicolon, okay? And I hit compile program. You're going to see that an error pops up. It's like warning, missing a semicolon. And if you look over here, it says 8. That means on line 8, there's something wrong. And if I look here, I'm like, oh, there's a semicolon missing. So then you can put a semicolon on there. I almost forgot something very important as well. We need a couple more lines of code. And that's because I mentioned earlier that code runs sequentially. So what it's going to do is it's going to run this motor for like a fraction of a millisecond, and then this one for a fraction of a millisecond, and then the program's over. But what we want to do is keep running these motors over and over and over again. So what we need to do is put them in something called a loop. A loop starts out like the following. Add some space if you need to. And you just need to create a condition. And a condition is written like this. So while, and then we're just going to use a parenthesis. 1 is equal to 1. And I'm using 2 equal signs because I'm comparing the value of 1 to 1s. So I'm not saying it's like equal to it. I'm saying while we're comparing the value of 1 and it's equivalent to 1. It's a little confusing, but I'm just comparing these two 1 values. And I have a question for you. When is 1 not equal to 1? Okay, 1's always equal to 1. So because that's always true, anything that happens within 2 squiggly brackets will always happen. So after this, I would like you to make a squiggly bracket by holding down the Shift key and pressing the square bracket next to P. And then on the end of this, after the 2 motors, I want you to do the opposite squiggly bracket. Okay, so once it enters your main program, it's going to get stuck in this loop. It's going to run lines 10, run lines 11, and then it's going to jump back up to line 8. And it's going to ask itself, is 1 still equal to 1? Well, 1's always equal to 1, so yeah, it's going to run it again, jump back up, and it's going to stay in here indefinitely. Okay, once you have this in place, go ahead, click compile program again. It should still be okay. And then make sure your robot is plugged into the computer. And if it is, click download to robot. It should start downloading it onto the robot. Give it a few seconds. Something's going to appear on the center of the screen or near the center of the screen. And eventually it's going to have a button on it that says start. Or something else is going to pop up that says your robot is off. If it says your robot is off, turn it on. And if you see the thing that says start on it, go ahead and press that. And if you notice, every time you press start, the robot's going to turn. And every time you press stop, it's going to turn off. So that means your program is working. Congratulations, you are now a programmer. Okay, I will see you in part 2, where we are going to program a button on the robot to control the motors. Okay, peace.